Okay, good morning. So today we're going to be graphing a system of equations, and that's going to be linear, which is a line, and exponential functions, which is either going to be an increasing or decreasing function. Okay, so let's take a look. Your calculator is going to be quite helpful. If you, for some reason, are operating with no calculator, you're going to have to use some skill set that you learned in 7th grade for graphing a line, which is knowing the slope and the y-intercept, graphing the y-intercept and using the slope to climb. For exponential, you can make a table of values. You could use the Desmos link that I have attached to my Google Classroom in prior lessons. Okay, so I'm going to start with g of x equals 2x plus 6. So if you look at that, I'm hoping by just looking at it, you realize which type of function that is. So what type of function do you guys think that is? Hopefully you are saying linear because the degree is 1. The x is being raised to the first power. So I'm going to plug in y1 and I'm going to plug in 2x plus 6 and I'm going to generate a table. And it's asking me for the y-intercept. The y-intercept is at 0, 6. So let's fill that in. I need a pen. Okay. And the slope is 2 over 1, so it is increasing. So I'm going to head to 0, 6. I'm going to put a dot. And then I'm going to go right 2, up 1. And I'm going to do that a couple of times. And then I'm going to go down to left 1. So it has a positive slope, so it definitely is an increasing function. You can use your table to generate these points, or I just used my slope and my y-intercept, and I am extending it. It's a pretty straight line. I'm pretty impressed with myself. G of x. What is the slope? The slope is 2 over 1. The domain, negative infinity, is less than x, which is less than infinity. A few of you guys think it's okay to have equal signs here. It is never okay to have equal signs with infinity and negative infinity. So please be aware of that. My range is also negative infinity is less than y, which is less than infinity. So that's my line. Let's move on to the second function, f of x equals 1/2 x plus 4 minus 3. So I'm going to hit my y equals, and I'm actually going to plug that in my y2. And I'm going to be really careful, parentheses, 1 divided by 2, close the parentheses, caret. And I'm going to plug in, it says x plus 4. So x plus 4 is my exponent. I'm going to right arrow out of that and plug in minus 3. So there's a whole lot going on with this exponential function. So it's definitely sliding. If you take a look at this plus 4, it's sliding left 4 because the inside is lying. The minus 3 is definitely telling you that it is sliding down 3. That's the vertical shift. The half should tell you that it's flipping over, hopefully you're saying this out loud to yourself, the y-axis. All right, so I've plugged that all in, and I'm going to hit second graph just to get some points. And I'm going to look on my calculator for the red stuff. That's going to help me figure out how to graph this. So I'm going to scroll up and down so I could look a couple of things that I can graph. Okay, so I don't think that negative 813 is definitely not going to fit. Negative 7,5 will fit on my graph. So I'm going to go there and put a dot. Negative 6,1 fits. Negative 4, not negative 6,1. Negative 6,1. Negative 5, negative 1. That's going to fit. Negative 4, negative 2. That's where it touches. Negative 3, negative 2.5. Negative 2.5. Negative 2.7. Negative 2. So it's getting really, 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 really close to negative 3. So the asymptote for this function is y equals -3. That would be I'll put it in green. That's actually the horizontal line. Didn't ask me for that, but I'm going to draw it in here anyway. So y equals 3, -3 is my asymptote. I'm just putting it in there so you can see it, not that you have to draw it. When you draw your systems, you don't actually have to put that in there. And I'm going to label this guy f of x. Okay, so approximately what is the y-intercept? So -2.938, it says. So 0, -2.938. At least that's what I got. It says approximately, but I'm going to see here. It's pretty accurate. Okay. Next. Is it increasing or decreasing? It's definitely decreasing. The domain, -infinity, is less than x, which is less than infinity. I'm looking at the red exponential function. The range, so the lowest y value is not actually equal to -3, but it's greater than. So y is greater than -3. Remember, equals -3 is the asymptote, and it's never touching that. So what did we say? This shifted 4 to the right. Right, that was a plus, right? Yes. 3 down, reflected over the y-axis. Are there any points of intersection? The answer is yes. There's actually 1 point, and that 1 point, you can look on your table, it's actually matching. It's -4, -2. You can see it in your graph. Your graph, it's pretty obvious. It's right here, right? But if you looked on your table and you looked at -4, you can see that they both have exactly the same number of -2. That would be your point of intersection. So let's think about this. When you have an exponential function, it could hit the line once. It could hit the line twice. It's possible. Or it could hit the line never, meaning no points of intersection. So it could be 0, 1, or 2 points of intersection. All right, let's keep going. All right, number 1, use your calculator to generate a table for f of x and g of x. And then, so this is graphed for you, which is kind of cool. So we're going to plug this in, and we're going to just generate the table like it says. So I'm going to do y equals, and I'm going to clear out both things that I have here, and I'm going to start by plugging in 1 divided by 2 in parentheses, caret x, right arrow out, -8. And then I'm going to plug in -15 divided by 4, x, -7. Hopefully you are recognizing that this is an exponential function. Hopefully you do. And that this is a linear function. So this has a little x as an exponent, and this has the degree is a 1 there. So that's linear line. Okay, for what values does f of x equal g of x? So I have a nice graph, which I could certainly use. I'm also going to generate a table because I did plug them in. And I'm going to look at my table, and I'm going to look to see where they actually match. So I see 0, -7. So it says for what values of x. So the points of intersection, you can write them over here, are 0, -7. I like that point. And then I see this other point, I think it's a -4. I'm going to look on my table. Yep, -4, 8. Those are my points of intersection. That's not what this is asking me for. This is asking me for what values of x does f of x equal g of x. So you got to be careful. The x values are here. So they're my roots almost. I'm going to put them in the little braces or squiggles, as you like to call them, 0 and -4. Write as an inequality the domain for when g of x is greater than f of x. Okay, so g of x is the line. That's this guy right here. F of x is my exponential function. So g of x, the line, is greater than the f of x. So you can write an inequality for when the line is higher than the exponential function. So green's above black, basically. So it starts at -4. It's not equal to, because then it would be exactly the same. X goes in the middle, which is less than, and it stops here at 0. Here and here, we don't really know. We can't really see. I think the line's below it, and the line is below it there. So this is my domain, which I like. -4 is less than x, which is less than 0. Write an inequality for when f of x is greater than g of x. Now they're asking me, when is my exponential function, the black function, above the green line? And that's basically in this section up here. Let me use a different color, like this section up here and this section down here. So I'm going to write when x is less than -4, or x is greater than 0. Again, I'm not including equal signs here because when they're equal to these numbers, these two functions are exactly the same. So this is asking me specifically when it's greater, f of x is greater than g of x. This is asking when g of x is greater than f of x. To be super careful in what they are actually asking you. All right, let's try the next one. You're going to get better at those as we keep practicing. Okay, what function family does h of x belong to? So let's take a look at it. That's looking like exponential to me. What function family does j of x belong to? Linear. What is percent of increase for h of x? So the percent of increase for h of x is, I believe, 100%. Because it has a 2 there. So it's basically 1 plus 1. So we're actually going to learn that more when we do exponential growth and decay, which we haven't done. So I'm not going to make such a big stink about this question yet, because you're going to learn a lot more about that. What is the constant rate of change for j of x? Constant rate of change is a fancy word for slope. Hopefully you know that. And the constant rate of change for j of x is 8, or 8 over 1. Use your calculator to generate a table and determine what the values of x make h of x equal to j of x. And then it says graph both functions on the set of axes below. Okay, so let's talk about graphing this. Let's do y equals. Let's clear everything out that we have here. Let's plug in 8 parentheses 2 close parentheses caret x. That's my exponential in my y1. And in my y2, I'm going to plug in my linear function, my line, 8x plus 8. And I'm going to generate a table by hitting second graph. Okay, so let's graph the exponential one first. So I'm looking at the graph, and I see it gets really close to 0, but doesn't touch it. Okay, so I'm going to start with -3, 1. 1, 2, 3, -1. And -2, 2. And -1, 4. 1, 2, 3, 4. And 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I don't know what else is going to fit on here. Let's see. 116, I think might fit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep, still fitting. 232. Oof. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I think I can squish it on here. All right, so So let's put that on here as well. Where did we say? Around here, I think it is. I don't remember. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, I think is there. Okay, I'm going to connect. And again, it gets really close to, but not touching the y-axis. It goes really high there, though, really tight to the y-axis. And we're going to call this h of x. Okay. It's 0, 8. How did I get this wrong? 1, 2, 3, 4, 5, 6, 7, 8. So I feel like this didn't really go as well as I'd like it to go. There we go. A little better. Yours will be much better than mine, of course. All right, let's graph the line. Let's graph 8x plus 8. So again, 0, 8. So that must be my point of intersection. And then I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8 over 1. Oop, another point. 1, 2, 3, 4, 5, 6, 7, 8 over 1. 1, 2, 3, 4, 5, 6, 7, 8 over 1. This is down 8, left 1. I think that's all I could do. It's a pretty steep line, though, actually. And it is j of x. Okay, so what are the points of intersection? The points of intersection are, I'm going to write them here, 0, 8, and 1, 16. That's where they're touching. It says, use your calculator to generate a table and determine what values of x make this equal to each other. So again, I'm looking at my x values. So I'm going to do 0, 1 in my little squiggles. Okay, I did graph both my functions. Please, 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 I'm begging you, label both. I have h of x and j of x. All right, let's keep going. Example number 3. Okay, so let's take a look at this one. We have 2/5 x minus 4. Hopefully you're recognizing the fact that this is linear. And we are going to plug that in our graph. So I'll put that in my y1. I'm going to erase anything that's here. I'm going to plug in 2 divided by 5x minus 4. Hit second graph and generate a table. And a lot of decimals. So I'm going to go with pretty numbers. So I'm going to start with -5, -6. So -5, 2, 3, 4, 5, 6, I think is there. 0, -4. I'm going to keep scrolling till I find nice things. 5, -2. And that's enough. I have 3 points. That's enough to really make a nice line. And it is a line. So I'm going to do that, and I'm going to label it g of x, linear. So who is the y-intercept? The y-intercept is 0, -4. Is it increasing or decreasing? It's definitely look like it's increasing because it's heading upward. Who is the slope of the line? It's 2/5. The domain, -infinity, is less than x, which is less than infinity. There's arrows on my line. Range, -infinity, is less than y, which is less than infinity. Again, no equal signs. All right, let's go on to the next guy. The next guy is exponential. Hopefully you recognize that by just looking at it. Okay, f of x. So I'm going to do y equals. I'm going to move down to my y2. I'm going to plug in parentheses, 1 divided by 3. Close parentheses, caret. That says x plus 5. Me and my old eyes can't read that. I have to make it bigger. Right arrow out, -7. Second graph, look at my table. Okay, so this is interesting. When I was looking at it, it has a whole bunch of -7s. I don't think it really has -7s. I think it just doesn't know what to do with those numbers. So I'm going to scroll up, and I am looking. So -820 is definitely not fitting on my graph. -7.2 will fit. -7.2. What's next? -6, -4. 1, 2, 3, 4. -5, -6. There's my point of intersection. -4, -6 2/3. So basically it's like getting really, 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 really close to -7, but it doesn't ever really touch it, although this calculator seems to think that it does. It is not. Okay, so if I'm looking at this is definitely flipped over the y-axis, and you know how I know that? I know that because the base is a fraction. It's less than 1. And that's f of x. Okay, approximately what is the y-intercept? So I have 0, comma, -6.996. It's pretty precise. Increasing or decreasing? I'm going to go with decreasing. Domain, -infinity is less than x, which is less than infinity. Range. So the range, y is greater than -7. It's not touching -7, but it's pretty close to it. What are the shifts that are happening here? Okay, so it went 5 left because the inside lies, so the +5 lies. It went 7 down, and it reflected across the y-axis. Are there any points of intersection? Yes, there are. It's at -5, -6. So you can look at your graph, or, so this is my point of intersection right here, or I can look on my table and it matches on the table. All right, that's pretty straightforward. Let's keep going. Silver we're on. All right, h of x equals 2. So this is interesting. H of x equals 2. It is a line. This is basically saying like y equals 2. It's actually a horizontal line. So let's actually just plug that in my calculator. So let's clear out all I got going on here, and I'm going to write y1 equals 2. And I'm going to generate a table, and like everything's 2. 2, 2, 2, 2, 2, 2, 2, 2, 2. So that's what my horizontal line looks like. So basically I'm going to go up here. I'm going to make a little bunch of dots, a 2, and I'm going to draw a very, a nice horizontal line and call it h of x. Again, yours is going to be much better. All right, so this is line linear, we'll say. This is exponential. Hopefully you're recognizing that. Under y equals under y2, I'm going to plug in 3 parentheses 2 close parentheses caret. And it says x plus 1, right arrow out of that, -1. And I'm going to generate a table for that one. Okay, so I'm going to start. So 223 is definitely not fitting. 111, I feel like, nope, doesn't fit. So 0.5 fits. So 0.5. So 111's like up here. I'll put it up there. 0.5, -1, 2. There's my point of intersection. -2, -1/2. -3, -1/4. And then we're getting like super close to y equals -1, but not actually touching it. So this is how this looks. And I'm going to call this j of x. Notice that both of my functions, linear and exponential, are labels? Okay, so let's answer these questions. Will j of x equal -1 exist? So will j of x equal -1? So no, because it's an asymptote. So I'm going to say no. It gets really close to it, doesn't really exist. Does h of x equal -1 ever exist? No, because it's always equal to 2. So that's a no also. All right, how many points of intersection? I only see one. What are they? Okay, I see, whether I look on my table or I look on my graph, -1, 2 is the only point where they touch. Why do you believe this is so? Okay, only touch once. Line is horizontal. Can't touch more than once if the line's horizontal, right? It's only going one way. All right, let's keep going. So silver, you have to stick with me. I'm gonna do sum it up. Gold, hang on a minute. I'll go back to gold in a minute. So I think I have a sum it up and an MC hammer. So I'm going to do sum it up first, MC hammer, and then gold last. When you're done with this, you can work on your homework. I think there's 4 questions for you to do on that homework assignment. And then I also posted a graphing assignment that you can do in Kami, and that's good for you. I would do that after you do the homework assignment. And you can even check that. You'll check that tomorrow. You can work on it tomorrow. You can work on it today, however you want to do it. But I would wait a little bit to do the Kami to make sure. I'm actually grading that Kami assignment. This time it's out of 12 points. So please make sure that you're doing an awesome job, because I'm not going to be having any give it back, raise the grade business. Okay? All right. So let's keep going. Sum it up. So we're on always, sometimes, never. Exponential functions have a restricted domain. Exponential functions have a restricted domain. So I don't think exponential functions have a restricted domain. I'm going to go with never. They seem to have negative infinity to positive infinity. Exponentials have a restricted range. Yes, I would say always. They always seem to have an asymptote. Exponential functions are increasing functions. Sometimes. Decreasing exponential functions are examples of exponential decay. Ooh, what happened? I lost all my work. That's not good. Ah! Technical malfunctions here. Okay. I don't know what's going on here. Okay. Back to again. Here we go. I got some ink. I'm going. Exponential functions have a restricted domain. Never. Exponential functions have a restricted range. Always. Exponential functions are increasing. Sometimes. Decreasing exponential functions are examples of decay. I would say... sometimes. Remember, if they're in the 3rd and 4th quadrant, they usually have neither growth nor decay. Linear functions have a constant rate of change. Always. They have slope. Give an example. Given an exponential in the form f of x equals a b to the x plus k, the a is the y-intercept. So not when there's a plus k going on there. Got it. I'm going to say sometimes. Depends upon what that k is. Okay, if the k is an asymptote, it's going to change what the y-intercept is. Given the exponential function in the form f of x equals a to b to the x power plus k, k is the asymptote. I'm going to say always. Linear functions have a restricted range. Restricted range. I'm going to say sometimes. That's only true for horizontal lines. Otherwise, I wouldn't think it would be. Okay, let's do MC hammer. Given f of x equals 2x plus 8 and g of x equals 2 to the x plus 5, for which values is f of x greater than g of x? All right, so let's look on our calculator. Let's plug in y equals, and let's clear out all the business that's in here. And I'm going to plug in 2x plus 8 in my y1. That's linear. And then I'm going to plug in 2 to the x power. And then I'm going to right arrow out of that and write plus 5. I'm going to generate a table, and they're looking to see when y1, in this case the blue, is greater than the red. So when do you see your blue function greater than red? Is that at x equals 8? X equals 0. So at x equals 0, 8 is bigger than 6. So that's true. Okay, what about 2? I'm sorry, how about 1 when x is 8? When x is 8, 24 and 261, that is not true. So say goodbye to that. I like this one so far. At x equals 0, I have 8 is greater than 6. When x is negative 5, I'm just going to look, negative 2 and 5.0313, blah, blah, blah. Nope. I don't like that one. How about when x is 5? When x is 5, I have 18 and 37. Nope. Still like the 0. I'm going with that. All right, Silver Friends, stop here and work on your homework, and then you can look at the graphing assignment for Cami. Gold Friends are going to come back with me, and we're going to go backwards to gold, and we're going to graph your line and your exponential function right now, and then answer these questions. Okay, so let's take a look at gold. So gold, this is my linear function. This is my line. And I'm going to go into y equals, and I'm going to clear out everything I have here. And I'm going to plug in 1 divided by 10x plus 2. And under y2, I'm going to plug in 4 caret x, right arrow over plus 2. And that's my exponential function. I'm going to hit second graph to get my table. And I'm going to be able, hopefully, to graph these. All right, let's erase this. I don't know if this is all going to fit on here, but we'll figure it out. Okay, so let's pick red for my line. So for my line, 0, 2, I like that. And then, is there any pretty points coming on here? Or what do we got? 10, 3. Well, that's really not fitting on here for me. And then what's the other one? 10, 3 is all the way to the right, and my graph moved over. What's the negative one? Negative 10, 1. And 10, let's see if I can get this going here. When I move it, I lose everything, which is so frustrating. Okay. All right, now I'm going to catch up. All right, linear, 0, 2. 10, 1, 2, 3. 10, negative 1. I think I did that right. Negative 10, negative 1. Did I do that right? 0, 2. That's a mistake. Didn't look right. 0, 2. Okay. Ooh, not so great. Okay. You're going to do better. G of x. Moving on. This is my exponential function. 4 to the x plus 2. I'm going to go to y. Oh, I did it already. I plugged it in. And I have 0, 3. 0, 1, 2, 3. 1, 6. 1, 2, 3, 4, 5, 6. 2, 18 is definitely not fitting. What about negative 1? Negative 1 is 2.25. Okay. 2 point, so it's getting close to 2, but not really touching it. So y equals 2 seems to be my, seems to be my exponential function. That is a really bad job graphing. All right, pardon me, but I'm not redoing it. That's f of x. Make sure it's labeled f of x, g of x. All right, will f of x equal 2 exist? So I'm looking to see if my exponential function will ever equal 2. The answer is no, because 2 is my asymptote. Does g of x equal 2 exist? The answer is yes. That's actually my y-intercept for my line. Are there any points of intersection? No. Why do you believe so? Doesn't intersect. Or it doesn't touch. So there are no solutions. no solutions. Okay, so we're all done here. Gold, you're going to stop the video here. You're going to work on your homework, and you're also going to work on your cami graphing assignment. Have a great day.